Oh, okay.
So I'll record too, but
Okay.
then she'll do it.
Okay, let's start with the end in mind. The end is, what's the function of the complement system? This is garbage. Okay, so what are the three major functions of the complement system?
Chemotaxis, oxidation, and lysis.
Who said that you should see the answer?
Me.
Good job.
Okay, so those are where we're going, right?
Mm-hmm.
So we have three pathways. We have the alternative we have the mannose binding pathway, the mannose binding lectin pathway, and we have the classical pathway. Okay, so the alternative pathway happens anytime there's an infection. Something about the infectious organism starts the alternative pathway. And it starts, here's our infectious agent there, it starts by C3b falling on top of it. C3b, that little black dot is C3b. Now where did that come from?
The complement system.
Exactly, the complement system. So the complement system is like 30 proteins are in what we call the complement system. The most abundant protein in the complement system is C3.
Yeah.
It's way more than any of the others. And C3 in the body, just want, all your extracellular fluid contains complement. Those 30 proteins, right? C3 being the most abundant. So C3 is in your fluids like this. It's C3, falls apart. Now it's C3b and C3a, right? Okay. And then there are things that deactivate it. If you're not infected, why do that, right? It's just that way. It's just kind of unstable. It's just falling apart all the time. But then it gets deactivated. But when you have an organism there, then C3b, I guess the big one is B,
Binds
to it.
becomes stable.
It's going to start. Now the mannan binding lectin, there's another protein in the complement system called mannan binding lectin, right? So it's a sugary whatever, right? So it's in the extracellular fluid. Now here's a bacteria, and bacteria happen to have mannose as a common sugar in their cell wall. Mm-hmm. So that will bind to this, that will bind there, and that starts the pathway.
What is that? The mannose?
The mannose binding lectin, which is another protein in your...
Binds to what?
Binds to the
Bacteria.
mannose.
Oh, it's the mannose.
Mannose is a sugar, and it's a very common sugar in bacterial cell walls, and probably also in their capsule if they have one. All right, so that's how that gets started. And then the classical pathway happens when you have antibody, either IgG or IgM, and it binds to antigen. All right, and then once it binds to antigen, it starts the pathway. It can start the pathway. All right, then there's different chemicals involved. Mm-hmm. Right. I personally don't care. Dr. Greg might.
He does.
He does? Okay, well then you got to know the chemicals, but do you want me to go through them?
Sure.
No, it's
Who grades these? Like with Dr. Greg?
Oh,
would
I
you?
grade mine, and he grades his. You'll have two tests.
Just give us what you would.
All right, what I care about is that there's different different chemicals involved, but through the different reactants, they're all going to lead to the formation of C3 convertase.
Yes.
Now, C3 convertase chemically is going to be different for the alternative pathway, the mannose binding lectin pathway, and the classical pathway. The molecules are going to be somewhat different, but they all act as an enzyme to break C3. Right? So now, once that's formed, we're going to get lots of C3 broken down into C3A and C3B. Lots and lots and lots. Right? And C3A will go off in solution. Right? It goes off and it's going to be involved in chemotaxis. Right? C3B is going to build up on the microbe. It's going to build up on the microbe. Here's our microbe. And here's my C3B building up on top of that microbe. After a while, in any of the pathways, after a while, there's so much C3B and a few other molecules involved, depending on the pathway, that you're going to form C5 convertase.
From C3A or C3B?
From the buildup of C3B on the surface of the pathogen, plus other molecules like properdin for the alternative pathway, other molecules for these two, okay?
Okay.
All right. But they all are going to make C5 convertase, which is going to take C5 is going to be split into C5A and C5B. Now C5A, we know, is involved in chemotaxis. C5B is building up now on the membrane. Here's C5B, okay? The big leg mark there, all right? That's going to build up now. C5B is on the membrane of the bacteria. C6 will come in. This is C5B. Then C6 comes in, and then comes C7, and then comes C8. It just boom, 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 right together. And then, so they form this big monster complex. And then comes C9. C9 is like a knife. C9 is a bunch of knives, and they polymerize, boom, go right through the membrane, form the hole in the membrane. So that is called C5B, 6, 7, 8, 9, is called the membrane attack complex, right? Membrane attack complex, or MAC. That leads to lysis of, a bacterial wall or something like that, bacterial cell.
It's called what? Lysis.
The membrane attack complex. All right. Now, what causes opsonization then? What's building up on this bacteria?
C3B.
C3B. C3B is involved in opsonization. Now, the most important things about the complement pathway, of the three functions, the more important are chemotaxis and opsonization. Okay? And lysis is nice when it happens, but you can do a lot. You can do more with these two functions. All right? Okay.
That was short and sweet.
That's complement in a nutshell.
Yeah, whatever.
Very objective.
All right, I'm going to go heat up my tea, and I'll be back.
Smart you too.